We'll start recording here. The law of definite proportions. Remember, a given compound always has the same amount of percent by mass. So in other words, sodium chloride, NaCl, has the same percentage no matter where I find it of sodium and chlorine. The law of multiple proportions is where they can combine in different ratios. Usually that's going to be for covalent compounds because they're sharing. So like carbon and oxygen, they can form carbon monoxide, carbon dioxide. That's the definite proportion, but that's the multiple proportion. The definite proportion is CO is always going to be the same percentage of carbon to oxygen. CO2 is going to be the same percentage every single time of carbon to oxygen in that one. Okay? I'm going through this part really quick because we're going to get to the stuff that we really need. This is just illustrating the law of multiple proportions and the ratios, so that in that's the case you would have N2O and that kind of thing. It's already all there for you, just kind of going over that real quick. We didn't even cover that in Chem 1. That you had to know the definitions for the test, and that was about it. Okay. These are just the laws that govern. Here's the Dalton's atomic theory. You should be aware of the two that were changed. What were they? It's right there, but y'all should remember that. Okay, subatomic particles, because we know that atoms are indivisible because we can divide them into their subatomic particles. And of course, number 2, all elements are not identical because we have isotopes. What are isotopes? Different number of neutrons gives them different masses, so they are in fact not identical. Their properties are pretty close to being identical, but they're not considered to be identical because of the isotopes. Here is Joseph Gay-Lussac. He was a French were very instrumental in early atomic theory. He was the first one to do experiments with gases, and he found that specific amounts of gases reacted with each other. He found that 2 volumes of hydrogen, 1 volume of oxygen gave them 2 volumes of water. Okay, and he was the first one to discover that. Avogadro took that principle a little bit further, and that's where we got Avogadro's hypothesis. At the same temperature and pressure, equal volumes of different gases contain the same number of particles. Okay. Does anybody off the top of your head remember what the molar volume of a gas at STP is? If you're close, it's 22.4. Yeah, 22.4 liters per 1 mole of any gas. Yeah. And that's at STP. Who remembers what STP is? Thank you, which is 1 atmosphere and 0 degrees Celsius. Resuming. Okay, so early experiments to characterize the atom. Occasionally on the AP exam, a history question may make its way in there, so you should just be aware. I wouldn't spend a lot of time focusing on it. J.J. Thomson, of course, he discovered the electron with the cathode ray tube. He postulated the ray was a string of negative particles that we now call electrons. He then measured the deflection, and he could measure the charge to ratio mass of its coulombs per gram. You will talk a lot about coulombs when we get to electrochemistry, which is next semester. So that's actually the last unit we do before the review. So you'll see a lot about that. That's where they came up with the plum pudding model that you may recall from Chem 1. And then they discovered that that's not exactly right. Thomas Millikan, yay for an American finally in the mix of the atomic theory. He sprayed the oil drops into the chamber of this device, and he discovered the mass of an electron, which is really, 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 really small. It's to the negative 31 kilograms. So that's kind of impressive that he could figure that out. Radioactivity, Henry Becquerel. You may have talked about him in physics. Did y'all talk about much nuclear in physics? He found out by accident that a piece of mineral containing uranium would produce a photographic image on the film. There are 3 types of radioactivity. This is basically all we're going to talk about radioactivity until we get to half-life. Alpha is the equivalent of a helium particle. It's the least penetrating of all the nuclear, so you can shield that with a piece of paper. Beta is your high-speed electron. It has more energy, and it can usually takes like lead to deflect that. And then gamma, it doesn't have any particles, so that would think a trick question on a quiz, like which one has the least mass. It's gamma because it doesn't have mass, but it's pure energy, and it is the most dangerous. And it takes about 6 feet of concrete or so to deflect that or absorb it. Gamma rays are they're a type of electromagnetic radiation. It's the highest energy of the EM spectrum, but it is very detrimental to human tissue. Unless you're the Hulk. Unless you're the Hulk, and then it's awesome. Okay. The nuclear atom in 1911, Rutherford. You should be aware of Rutherford. He's the gold foil guy. He sent the particles through thin sheets of gold foil. He was expecting them to all pass through, but some were deflected. And it was actually, even though they're small particles, it was like the equivalent of a cannonball going through gauze. And that's how they discovered that the plum pudding model wasn't correct, because there was some positively charged entity somewhere in that atom. Okay? So he was a gold foil guy. So you should know Rutherford, gold foil, Thomson, cathode ray, Becquerel discovered radioactivity. Those are the kind of highlights you should know. So he decided, oh, nope, not a plum pudding model. And then that, I believe, brings us to almost to the modern view. This is just more of the nuclear dense. They decided, okay, there's a dense nucleus in the middle, which we now know to be correct. Most of this mass comes from the nucleus. Where does most of the volume come from? See, y'all remember this stuff. That's why I get to go fast. All right, the modern view. Elements, all matter composed of only one type of atom is an element. There are 92 naturally occurring. What's the last naturally occurring? Uranium, you are correct. All others are man-made, okay? We are now up to 118. 118 elements have been made or discovered, named. So they are starting work. They started this year on trying to, I told you, if you were in pre-AP last year, I told you this. They're trying to start working on 119, which means in your lifetime you will see a new period added to the periodic table. We'll go to period 8, because 119 would come next after that, because 118 has a completed 7p shell, so that means we'll go to 8s, and you'll get element 119. So that's... Well, this is anything above 92 is man-made, okay? So 119 would be man-made, but it's considered an element because they create it, and it's just the protons and neutrons. But they are working on creating 119, so you could see a new period added to the periodic table, which is kind of cool. Yeah, it's kind of cool. I don't know. Oh, is that what you're asking? Oh, I mean, it's possible. There could be unobtainium. That was what movie is that from? Vibranium. Unobtainium. Isn't that from like? What was the movie with the blue people? Avatar. Thank you. Thank you. Okay, moving on. Atoms, of course, are the smallest. The nucleus contains protons and the neutrons. They're very dense. Protons positive charge, neutron neutral charge. They're what responsible for the isotopes. The proton and the neutron, while they're not exactly the same exact mass, they're so very close to the same. They're just slightly different mass, and they have they're still very, very small, but they have like 2,000 times the mass of an electron. Okay, and so there's your parts of the atom. There is your charge. There's your mass. There is your atomic symbol, which you need to know how to do and determine how many protons, neutrons, and electrons there are. The mass defect is the difference between what we expect the mass to be and what it actually is, because there's a little bit of difference. But I don't think that would show up on an AP exam because they don't talk about that. Remember the mass numbers on the top. Mass number is protons and neutrons together. And then the atomic number is the number of protons. So it's just a little subtraction problem to get to neutrons, right? There are two different ways that you can see that mass symbol. You can see it where it's a dash with the atomic mass number. or you could see it as the other one. So they're telling me a mass number of 19. So I could write that as fluorine 19, or I could write fluorine 19 and 9. And so how many neutrons would there be? 10 neutrons, 9 protons, and 9 electrons, because this is neutral. Okay? However, how often do you find naturally occurring fluorine atoms in nature?
Never.
Never. Exactly. If they have fluorine gas, they've created it and they have to keep it that way. But naturally occurring, it's too reactive. Remember, fluorine is the most reactive of the nonmetals. It's also the most in something else. I drilled this into my kids. Fluorine is the most what? Starts with an E. Electronegative. Yeah. Electronegative. Means it wants the electron more than anybody else. Okay? Electromag. What did you say? Okay.
Wait, is it magnetic or negative?
It's electronegative. We'll get to that. Electronegative is the ability to attract an electron in a reaction.
But I mean, like, if you broke apart, like, the parts of the
So, okay. So, in layman's term, what does that mean? That means fluorine is going to always win the battle of the electron. It'll always take the electron. That's basically what it means.
But isn't that kind of the same thing as, like, the...
Right. So that's how we do the mass number and atomic number. Isotopes, of course, have different number of neutrons. The only ones that get special names are your hydrogen isotopes. The most abundant form of hydrogen actually doesn't have a neutron, and if it has one neutron, we call that deuterium, and if it has two, we call it tritium. Sometimes if they make water out of deuterium, sometimes it's referred to as heavy water or heavy hydrogen, because it has a neutron, whereas most forms of hydrogen, the most abundant form, does not have a neutron. And it, of course, is the only element that can not have a neutron. Molecules and ions. Yay, here we go. Electrons basically is what we care about when we're talking about reactions, because they're the ones that do all the work. They're either going to be sharing or transferring. Yeah. So chemical bonds are the forces that hold the atoms together. Covalent bonds, of course, are sharing. Sharing is caring. Don't be ionic. Be covalent. When we get to bonding, remember there's two types of covalent bond. There's polar and nonpolar, and that's equal and unequal sharings. The molecule, of course, is the smallest unit of a compound that retains its characteristics. Molecules are covalently shared. We do not refer to ionic bonds as a molecule. Okay, don't make that mistake on the AP exam. Molecular formula, of course, is your symbols. C2H4 would be an example. And then your structural formula is what we actually draw. That's where we would draw it with the lines to kind of show how it looks. Okay? Ions, of course, are formed when electrons are lost or gained. Which ones are positive? Yes. There you go. Thank you. My kids know. If you were I don't know if Miss Lawrence said it, but we say cations are positive.
Teachers, assembly 2 group.
Meaning that they have lost electrons, and anions are negative, they've gained electrons. Remember your polyatomic, that's where they're covalently bonded, but they have a charge. Those will be the ones you miss on the ion test because you won't study. If you study, those are the harder ones. Like, what is sulfate?
SO4 minus.
SO4 minus. Sulfite?
SO3 minus.
SO3 minus. If you've got an 8 and an ite, remember the 8 always has higher oxygen because it ate more oxygen. And the other one's like, I've had enough. I don't need any more oxygen. Okay? Ionic solids. Okay? Electrostatic forces are holding these together. So there's the opposite charges. When these electrostatic charges are strong, the ions are held together tight and close. Additionally, the stronger the Coulombic force, we're going to talk a lot about that this year, is the higher the melting point. Coulombic forces or Coulombic attractions are huge AP buzzword on the AP exam. I promise you'll answer at least one question with those in there. We're going to vaguely talk about it today, and then as we get into bonding, we'll talk about it more. Okay? Very important AP concept. Put a star by it, circle it, you got to know. You do not have to do calculations with the Coulomb's law, okay? But you have to understand it. And basically, the higher the charge, the higher the Coulombic force, or the attraction, or the smaller the distance. So the closer the ions are able to get to each other, also higher the force, okay? So you have to understand that. That's all I'm going to say about it today, because we're going to go into it several times. There will be lots of practice questions where Coulomb's law shows up. But the basic gist of it is higher charge or smaller distance means a higher Coulombic attraction. So usually they'll have you compare melting points and say, why is the melting point of this stronger or higher than the other one? And usually you can look at it, if one of them has a higher charge, or if it has a smaller distance between the ions, then it's because it has a higher Coulombic attraction. They won't tell you that. They'll expect you to know based on the size of the atoms or the charges. But we practice it a lot. This is like basic intro to Coulombic attraction. Okay. We already talked about that. You know where the metals are. You know what the metals' properties are. I don't need to go in that. You know that groups or families are up and down. They have similar properties. Periods are across the rows. And then, of course, you need to know that group 1 is your alkali metals, group 2 is your alkaline earth, all the things you already know. Which one is group 17? Yeah, it's the halogens. Lanthanide and actinide are on the bottom, that kind of thing. And so here we go. Naming is what I'm trying to get to today. Okay? I'm not going to read all that. You can go back and read it. We're going to do a quick review, just verbally, because you can read. If you are naming an ionic compound, the metal keeps its name, and then whatever is behind it, if it's a non-metal, it changes to IDE, right? So sodium chloride, calcium bromide, potassium hydride. Yeah, hydrogen goes to hydride. That's the one that gets people. Strontium sulfide, that kind of thing. If it is a polyatomic ion, it just gets its name. So calcium sulfate, ammonium nitrate, that kind of thing. So it keeps its name. If it has more than one charge, what do we have to include? The Roman numeral. Okay, and the Roman numeral is not telling you how many there are. What is the Roman numeral telling you?
The charge.
The charge. Okay, which ones need Roman numerals? The transition metals, except there are 3 exceptions.
Mercury.
Nope, not mercury. Silver,
Gold. And copper.
silver, zinc, and cadmium. Oh, good job. That's I forget that one sometimes. I always have to think. Okay, silver is what charge? +1. Zinc and cadmium are +2. Okay, so you don't write a Roman numeral with those. And then, not in the transition metal, but tin and lead are a +2 and a +4. Okay, on the AP exam, you will not see the old naming system of the ick and us. You should recognize it just in case you get a worksheet that says ferric nitrate. You know that the ick is always the higher of the charge. So anytime you see cupric, ferric, stannic, it's always the higher charge that it can have. In pre-AP, y'all, the seniors were made to do that with Miss Lawrence. I did not do that last year with the juniors. I said, it doesn't show up on the AP exam, we're not worrying about it. Okay? But you should just recognize ick is always the highest charge. Okay? Same thing with, if you're talking about acids, ick is always the higher oxygen. Okay? It's up there. Is that how you said cadmium, or did you remember it on your own? I was impressed. You know what? You can have a starburst for being honest. Come get a starburst for being honest. Okay.
I'm honest every day.
Okay.
Please.
Monoatomic. I already said all this. Okay.
You mean to be honest? I didn't really.
There's your charges. Blah blah blah. So let's just practice. I know the answers are on your paper, but let's try not to look at them and see if we can name them and remember. So what would A be? Cesium fluoride. And B? Aluminum chloride. Cl is chloride. Chlorate is ClO3. Okay? Chlorate is ClO3. Hypochlorite is ClO. Remember those? And remember on that little pink sheet where I have like chlorate, perchlorate, you can interchange the other halogens with it. So you could have hypobromite, you could have hypoiodite, okay? And then what would C be? Zinc.
Lithium hydride.
You missed that one on a quiz, didn't you?
No, I got a 20-something on it.
Yeah. Yes.
How many?
They're listed there in the notes. Next.
Like, how do you know when to do 8 or I?
Ide is any non-metal. When it's the second thing, it's always ide. So any individual. The other ones are the polyatomics. Okay? So if it's sulfate on your paper, you're just going to name it as sulfate. Okay? So if I had, well, y'all have all these answers on your paper, don't you?
Yes.
Let's make up new ones then. Okay? What would you name that one? Sodium sulfide. I'm going to give you different examples since they have the answers on that one. So that would be a binary. Binary means just two things, right? And two elements. And this is ionic, so it's going to be a metal and a non-metal.
Would that not be Na2S?
It would be. You're right. Thank you. I'm trying to.
Oh, do I get a Starburst for being honest?
You get a starburst for catching my mistake.
So
Yeah.
you see how
Sodium's a plus one. Well, hey, let's just name them right now. We'll do charges in a minute. Shh. We're just going to name right now. We'll do putting them together in a moment. Okay. Now let's do this one.
From anode to cathode.
Calcium bromide.
When would it be calcium bromate?
I'll get to polyatomics for that. Let me get to right now. I'm just doing binary. Just doing ionary, binary. Okay, let's do these. These are already named, so let's do our own. So that one is Cu. What about this one?
Ferrate, chlorate.
No, don't use
Is
the
that copper?
Iron
Cupric
oxalate.
chloride.
copper 2. Thank you. It's copper 2 chloride.
wait, it changes because it's got.
Copper is a transition. It can be a +1 or it can be a +2. We have to say which one it is. Because chlorine is always a -1, the fact that it took 2 of those to go with the copper, it meant copper was +2. Yes?
What if it's a copper or like one of those with a metal? How do you name it? Because you can't do iron.
What do you mean if it's a metal? That is a metal.
Chloride is a metal?
No. Ionic compounds are metal and nonmetals, remember?
But how do you name it if it's two metals?
That's
It's not a name. It's going to be an alloy. Brass, bronze.
So is it always iron at the end?
Yeah.
Unless it's a polyatomic?
Yeah. Metals, when metals share, they form metallic bonds, and we call them alloys and mixtures.
So it's only chlorine iron if it's a polyatomic ion? No.
Correct.
What's a polyatomic ion?
In the brackets on the pink sheet.
Okay.
They're covalently bonded, but they have a charge. So sulfate, sulfide, SO4, SO3.
They act like one thing.
Yes, they do.
So they could go with like a copper and it'd be like copper, sulfate, and it would be.
Yes, but I haven't got to that. I'm doing binary right now. Yeah.
I know what binary is.
Binary means two things. Two things. We're going to go over that. Yes. Okay. No, you're fine. Okay. All right. So this one was copper 2 chloride, but this one right here would be what?
copper 3.
Copper 1 chloride. Okay.
I can't see the screen.
Okay, you know what?
It's like a water mask.
Okay. What about this one?
Wait. Lead.
Lead 4 oxide. Okay? Because oxygen is always a -2 unless it's in a peroxide, but this is not a peroxide. I will tell you, usually it's not a peroxide with a metal. Okay? So that would be lead 4 oxide. Okay? What about that one?
Tin oxide.
10. Because oxygen is a 6.
Oxygen's a -2. So that means that tin has to be a +2 because there's one of each.
Yeah, I actually missed out on the quiz that I got like a 30 and it was like oxygen.
Okay.
I put like, I would like just go.
Any more questions on binary? Just meaning it's going to be a metal and a non-metal.
So you always put like the numbers in if it's not silver, zinc, or
Yes, if it's if it's any element, whoops, if it's any element that can have more than one charge, you have to include the Roman numeral.
Back in.
Remember, it does that sometimes for some reason. Okay, so pause the talking, and if anybody has any more questions about binary only, we're going to go over the other ones. Remember, binary is they're talking about ionic binary, so it's just a metal and a non-metal. Okay. That's the last thing's always going to be IDE, no matter what it is. The first thing just keeps its name. You only put the Roman numeral if it's can have more than one charge. The things that can have more than one charge are your transition metals in the middle, groups 3 through 12, with the exception of zinc, cadmium, and silver. They don't get Roman numerals. And then tin and lead are pseudo-transition metals because they are acting like they are with the two different things. Okay? All right. And if like on the ion test, I'm giving you the Roman numerals because I have to. Like it'll say 10-2, so you write SN2 plus. Now you got to get the symbol right, okay? But so when you think that that's a hard thing to study, if you look at what you actually need to memorize, it's not near as much as you think it is. It's basically all of the last group because they're all polyatomics, and a lot of I think the fourth group is polyatomics. But a lot of that you don't have to memorize. You got to know their symbols, but they're up there. I'm not covering that up. Their names are not underneath it. Yeah, no, but I feel like if you look up there, you could kind of get them. You can't read that from here. Yes. Yes. Okay, so we did binary. Now let's do polyatomics. Okay. So this one, what is A?
Sodium sulfate.
Sodium sulfate. Try not to look at the bottom. Let's see if you can name it without. Okay. How about C?
Iron 3, nice.
Y'all are reading them, aren't you? No, I'm going to fix you. Let's just do this. What would that be?
Tin, 2, sulfate.
Okay, I can't resist. I have to do that. Since they were there. Okay, how about...
wait, I didn't.
Calcium hydroxide.
Y'all getting the hang of it? Is it coming back to you? Especially my seniors who haven't done this in a really long time.
Yeah, like 2 days. I just practiced.
Uh-huh.
Like 10, like said it didn't get up from.
It did. Why does it?
So that you said it was like one of those weird ones.
Because it can be 10 is either going to be a +2 or a +4 charge. So you have to tell the reader.
Okay.
Yeah.
So it's not
So if it was like this, then that would be 10-4
Okay.
sulfate.
Because you could.
Because since we know that sulfate is a -2 charge, and it took 2 of them to go with the 10, that means it's got to be a +4.
Okay. Thank
Okay?
you.
Yes?
If you have like one of the ones where it has like more than the polyatomic ion, does that mean you're with the transition?
No. Because look at calcium hydroxide. Calcium has 2 hydroxides because it's a -1, but calcium is a group 2 metal, so it's always a +2.
Does that change the name when you have more than one?
No.
Like even if it was like something that went with OH and regular?
Okay, I think I know what you're asking. She's asking if you have more than one polyatomic, does that change the name? Not in an ionic compound, no, because ionic compounds can, ladies, ionic compounds can only go together in one way based on their charges. So you're thinking of the prefix system, right? Like di, tri, that's for covalent compounds that are sharing. That's a different kind of compound that we recognize in a different way. Ionics or metals are always going to, except with the one exception of ammonium, which is NH4+, your ionic compounds will always start with a metal. And that's how you recognize that they're ionic, is do they start with a metal. With that exception of the NH4, that's the one and only positive polyatomic, and that bonds as an ionic compound.
Yeah, help me.
So if that was like the CaOH2, if it was like something that just had one OH,
It would still be, no, because it wouldn't, well, I see what you're saying. Let me,
what's the metal was at -1?
I forgot how to,
And then we can find the pH.
so this would be, this is just sodium hydroxide.
So it doesn't create, okay.
You shouldn't be putting a prefix with the polyatomics because they're bonding as ionic. And that's because sodium is a +1, hydroxide is a -1. So that's the only way they go together. Whereas calcium hydroxide, calcium is a 2+, hydroxide is a -1. So it takes 2 hydroxides to go with calcium. That's the only way they can bond together. So we don't use prefixes.
Still like calcium hydroxide.
It's calcium
It
hydroxide.
doesn't go to like hydroxide.
No.
Okay.
Okay? All right. So now we're going to do covalent compounds. And before we do covalent, the metallic ones don't have a name. That's like bronze and brass, and because they're alloys. So let's remind ourselves, this may even be in the notes, I don't know, but let's remind ourselves, what are the prefixes for these numbers? 1. Mono. Tetra. Hexa.
Okay, you know what?
Okay, we're not going to go there. Yeah. Okay. Okay, so let's talk about the rules for molecular before we go into it. So everybody be quiet, because molecular compounds, okay, that's going to be what? 2 nonmetals. 2 nonmetals. So if there's not a metal present and you see 2 nonmetals, that's going to be, use your prefixes, okay? The first thing keeps its name. So if it's like carbon and oxygen, it's going to be carbon, okay? The only time that the first thing gets a prefix if there's more than one of them, okay? If there's more than one, it gets a prefix. If there's only one, it doesn't get a prefix, okay? The second thing always gets a prefix. Even if it's just one, it's mono, okay? And it changes to IDE, right? So carbon monoxide is CO. Carbon dioxide. So the second thing is always going to be an IDE, okay? And it always, always, always gets a prefix, okay? Yes?
Is it when the second one like gets hydrogen with it, it's like changed to like hypo?
So it can change to like, so you have CO3 is carbonate, which is a -2 charge. If you put a hydrogen with it, we call it bicarbonate, and then it's HCO3 with a -1. However, it's also correct to say hydrogen carbonate.
Attention.
When you have oxygen and you're putting a prefix with it, if the prefix ends in a vowel, you drop off the vowel, because penta-oxide would be weird. Okay? How about this one?
Calcium.
Not calcium. Chloride.
Let's do one with the 1 as the second.
Okay, we can. That would be carbon tetrachloride. Okay? How about this one? Dinitrogen monoxide.
There was a tricky one on the. What was the tricky one on the quiz?
Okay. Yes?
Is it ever oxygen first?
Yes, you can. There's actually this one.
That's
What is that?
OF. That would be oxygen monofluoride. Yeah. It's not that common, but it is. Yes, Zeke.
If there's only like one, and wait.
One what? Then it's an element. It's not a compound. Yes.
They're really
Do you always put a prefix on the second one no matter what?
Okay, wait, one question at a time.
Oh, I thought you were.
Yeah, so yes, you always put a prefix on the second thing no matter what. The first thing only gets a prefix if there's more than one of them. What was your question, Michaela? Oh, yes. Okay. All right. That's I like that. Let's do another one. Okay, yeah.
Like if you put SO3 and make
I know. I'm glad you said that because that's the one. What would this be?
sulfide.
No.
I have a legit question.
Those always get
Oh dang. Sulfite.
Okay, let's talk about that because that one got a lot of people on the quiz last year. SO3 without a charge is sulfur trioxide. If it has a charge, it is now sulfite. So if I had this in a compound, what would that be? Sodium sulfite. Okay? But just SO3 by itself, without a charge, is sulfur trioxide. Okay? And I put that on the quiz, the naming quizzes every year, so I can clarify that, and it catches them every year. Okay? All right. Yes, Z.
If it's H2O, do you want us to do dihydrogen?
No, if you look in your notes, there's a list of things that have been around for so long they're known by their common names. Water is one of them. So I don't have the list in front of me, but like this is, what is NH3? Ammonia. NH4 plus is ammonium.
So what about just NH4 period?
There is not an NH4 without a charge. It's got a charge. Okay? Salt would still be sodium chloride because that's an easy enough to change. But you should, the reason being, over here. The reason being is when we say something is a salt, okay, we're not just talking about NaCl. Salts are a class of compounds, remember, that happen when acids and bases react. So magnesium chloride is considered a salt, okay? Table salt. If you say table salt, then you're talking about sodium chloride. But you wouldn't really, you might see that in something, but table salt, yes. Sodium bicarbonate is baking soda, NaHCO3. Sodium bicarbonate is what we call baking soda, okay?
To like do something to an acid?
That's what you use to neutralize it, yes, yes.
Okay, wait. So is there a chemical difference to table salt and sea salt?
No, one's coming.
Like, on a molecular level?
Well, so pure table salt is usually pure NaCl, although most of it is iodized because it's healthier. Sea salt often has some other minerals in it, so it's not, sea salt wouldn't be considered a pure compound because it's got other minerals in it. But sometimes you're just paying more because it's sea salt and fancy. But there are some minerals in there, but then it's not a pure salt. Most table salt's not pure either because it's been iodinized. They add iodine to it because our body needs that, and they found that when they did that years ago, whatever, I don't remember what the condition or disease is if you don't have enough iodine in, but that helped take care of that.
Goiter.
Okay, there you go.
What about pink Himalayan salt?
Again, to make it pink, it's got some minerals in there. It's not a pure compound any longer. Okay? Now let's talk about some acids.
I love acids.
Dude, acid's my favorite.
Okay, so I would like you actually to be really quiet on the acid part because some of you probably aren't going to remember the naming of the acids, okay? There are two basic types of acids, okay? There is a binary acid. What does binary mean? Two, which means it's hydrogen and one other thing, okay? When there is not any oxygen present, it's going to probably be in a binary acid. So that's where you have like hydrogen and fluorine would be hydrofluoric acid. So you add the hydro prefix in there if there's no oxygen, and it's a binary, okay? And then you are going to just name the second thing to ic. So HCl would be hydrochloric acid. Okay, HF is hydrofluoric acid. H2S would be hydrosulfuric acid. So if there is not any oxygen present, you're going to have to use that hydro, okay? And that's how you know it's an acid. First of all, if it starts with an H, it's normally an acid, except for water. Water can actually be both an acid and a base, if you will. Okay? Okay? All right, so if there's oxygen present, it's usually going to mean that it's hydrogen in one of the polyatomics. That's where we do that 8 to ic and ite to us. Okay? So if it's a polyatomic that ended in 8, we change the prefix to an ic. If it's a polyatomic that ended in an ite, we change it to an us. You might want to write that on the bottom of your pink sheet somewhere. 8 to ic, ite to us. Okay? The way that I tell my kids to remember it is the one with the more oxygen, 8 more oxygen, so it feels icky. Okay? And the other one's jealous because it doesn't have as much oxygen as the other one. That's one way to remember it. Okay? Just little tidbits and things to help you remember things. Okay? Ite. That's lower oxygen. Okay? So let's name these. I know they're on your paper, but let's just do it. HBr, no oxygen, so we use hydrogen. So hydrobromic acid. Oops. Sorry, I forgot to say I was writing. Okay, so if you look on your pink sheet, under group 2, do you see where it says perchlorate, chlorate, chlorite, hypochlorite?
Yes.
You can substitute the other halogens. So BRO would be hypobromous. So when we name that acid, it's going to be it's going to be actually it'll still just be hypobromous acid. Yeah, so we just name it to hypo, because it would be hypobromite is what it would be as an ion, so we change it ite to us. Perchlorate, here they have it here. So this would be bromate is the name of the thing, so we would call that bromic acid. So we still follow the 8 to ic and ite to us. But if it's got that hypo or that per in there, we include it. Okay? Does that make sense?
Yes.
Okay.
Nitric.
So these are just some practice naming ones. So what I gave you, because those answers are there, what I gave you today was a worksheet that has them all mixed in, so you can practice. Okay, the rules are listed. I don't like to read over the rules. You can read. Some of you are remembering. My juniors probably remember naming a little bit better than my seniors, just because it's been longer for you guys. But it does kind of come back to you. If you were someone who never really got naming down and you didn't do well on the naming quizzes, then you might have to practice a little bit more. I know there's 2 kids in here that took regular. Y'all didn't take naming quizzes, so you didn't take the same kind of naming quizzes that pre-AP did. They did weekly quizzes on the computer for like 10 weeks, you know. So you might have to practice it a little bit more. There's all kinds of naming practice on online. On my pre-AP, I have a website. I guess I could throw it on regular. I might throw a link on the Canvas so you can go practice it. Yes, I think your name is Daniel.
Wait, so
There's a few of the seniors I don't still know.
the pentaoxide thing, is it just pentoxide? Or do I put the A there?
No, so like if you have, so for oxygen you would do like pentoxide. You just do pentoxide. Leave the A out.
Okay.
Yeah, sorry. Like if you're doing iodide and you put tri, take off one of the I's, so you would just have triiodide. Because if I wrote it like this, doesn't that look really funny?
It looks like it's weird Latin.
Yeah, so just use some common sense in taking off. Yeah.
That'd be the apple.
Yeah, you wouldn't do monoxide like that. Take it off.
Hey guys, settle down.
Guys up.
There's hydro, like with an acid on it, where it's hydroiodide, we leave the O behind.
So on the worksheet, there's what is it?
It's HI.
Oh, that's the friendliest acid. It'd be hydroiodic. There you do keep the, so That would be HI. Whoops. I'm having some issues.
That's what it sounds
So HI,
I don't know why I thought
that would be hydroiodic acid.
we were talking about like the
Okay? All right, I'm going to stop the recording.